Okay, so we want to go from rectangular to polar form. Here I have an example so we can explain all the process from going to rectangular to polar form. So here we have the example plotted into a Cartesian plane so we can understand better what we have to do. So first step, calculate r, which is the distance, is how long is our vector. And we can calculate using Pythagorean theorem, as we form here a right triangle. So the hypotenuse would be equal to r, to our distance. And we have both values of a and b according to our rectangular form. So we just calculate using the Pythagorean theorem, as I said. We substitute the values and we get that our distance is equal to 4. The next thing we have to do is calculate our angle. So this angle here, alpha angle. And we can do that with this formula over here, which we will be using trigonometric ratios, tangent in this case, of b over a, of opposite over adjacent side. But before calculating this, there is an important thing to point out with these angles. And remember, we have the quadrants, right? So if we have our angle calculated with this formula over here on the quadrants 2 or 3, to get the alpha angle, so the angle with respect to the positive x-axis, we have to add either 180 or pi, depending on what units we're working with. Else, so we have, as in this case, if we have our vector and angle on quadrant 1 or 4, it's just the same. We don't have to do any extra step. So let's go ahead and calculate our angle. And we have that it would be equal to 30 degrees or 0.52 radians. And we have all our information just to plot into the polar form. So here we have what would be the polar form. We just have to substitute our values according to what we just calculated. And there you go. We have in both degrees and radians our final answers. So that's it. So now we're going backwards from polar to rectangular form. So here we have our polar standard form, just to remember. And we will be solving just the same example that we did on the last example, so we can check that actually works. And this is exactly the same we got on last video. So here we have a kind of an Argand diagram. It is not the Argand diagram of this example. It's just for understanding how this process works. So here we have our Argand diagram, and here we have this green arrow is the vector of the complex number, right? So we remember that these form a right triangle, and thanks to this we were able to calculate r, which is the hypotenuse of this right triangle. So we had a, b, the hypotenuse, and the angle formed in this right triangle, which is alpha. So with all this, we were able to calculate our polar form from a rectangular form, and we will be continue to use this. So we will be using here our trigonometric ratios. So we know that cosine of the alpha angle is just adjacent side over hypotenuse, which is the same than saying A over R. And the same happens with B. So the sine of the alpha angle is opposite side over hypotenuse, or what is the same, B over R. So I think you are starting to have an idea of how we're going to do this. So for having the rectangular form, we need two values, A and B. That's it. So the only thing we just have to do here with cosine and sine of the alpha angle is solve for A and B. And that's what we will do. We solve for A and B, so here we multiply both sides, R, here it cancels, and we end up with this formula. So we have that A is equal to R times the cosine of alpha angle, and B it's equal to R times sine of the alpha angle. And we substitute the values of our example. 4 times cosine of 0.52, this is the angle, remember, in our polar form. In this case, we have it in radians, but in degrees would work exactly the same form. Just the unique extra step that you have to make is that you must set your calculator to the correct unit, either radians or degrees. So after pointing out this about the angles, we just do the same with B, but instead of cosine is sine. And the results, here we are, of A and B, they are not exactly the same than those we start from on last video, but that's just because the roundings we've done with both the distance and the angle. But here, as you can see, we can round 1.98 to 2, and this is just only one. The original, I think, was 3.46, so it's almost the same. And the only thing that we have to do then is to substitute in a rectangular standard form, and we end up with almost the same equation that we had starting off the previous video. So that's it. Thank you. Goodbye. See you on the next video.